since my focus has been on containers and Kubernetes, I was always heard the term GitOps earlier. And last year, I was here at All Things Open, and I attended a session that pushed my curiosity to the next level. I went back and I saw my first Git repo, which I tried with GitOps, was November 16th, so right after this. And since then, we started with a very small application, wanted to expand it and see how we could use it in our test automation. I'm someone who gets like a lot of ideas, but I know if I say, oh, I have an idea in front of someone, especially my kids, they're like, no, please, no more ideas. So instead of that at work, what I do is just create those tasks and tell people like, oh, this is something if someone is interested. And that's how Dan got interested. He doesn't know he's victim of my ideas. He took it to the next level, and then we got all our team involved, and so that's something we'll be showing. So Dan, you want to introduce yourself with that?
Yep. Hi everyone, I'm Dan. I work with Monica on SVT, and I'm used to moving around. Hi everyone, I'm Dan. I work with Monica on SVT, and like she mentioned, I fell victim to her grand plan.
Yeah, I can.
Just use the arrow key.
Yeah. So for today, we will be sharing our focus, will be sharing our journey, how we got started with this, what were the challenges, how we overcame. Before, with that, we will cover a little bit of background on what were our goals, what were our needs. With technology changing so fast, by no means we consider ourselves as the experts on this technology, but sharing our journey. So if you have your experiences, we would be happy to learn from you as well. Before we get started, just a couple of, I wanted to know what's your experience like. So you all are familiar with containers, Kubernetes, most of you, I imagine. How about CI/CD tools like Travis Jenkins, and people who have used GitOps already? Wow, okay. Anybody attended yesterday's Flux CD session? Okay. Yeah, we will be talking different, so it won't be a repeat. So before we talk about what we did as part of automation, I just wanted to give you a quick idea on what we are trying to do with this automation. On the left are the products, open source product, Open Liberty being our lightweight runtime, Java runtime, which is production ready, and it's perfect for cloud native applications. And then we also have operators to deploy those applications to Kubernetes. Those operators make it easier because you don't have to worry about creating deployment, service, routes. It does it for you. It takes out some of the complexities of the Kubernetes. So as I mentioned, that our job is to test these products. So how would we test these products is how we consider ourselves as first customers. So what would customers do with this is write their application, mission critical applications, right? They will develop, deploy, upgrade. So we want to do the same things. As far as deployment is considered, our customers are everywhere, on-prem, private cloud, OpenShift, Kubernetes, so we intend to do the same things. So again, we have about 10 applications which we use to test those runtimes and operate different operators to deploy these. And some of these applications also include DayTrader. Some of you may have known those, and Acme Air. These are open source apps. And we have also homegrown applications. And most of these applications, we need some kind of database. So we would need to have those as a prereq. And also in test, we use Jmeter, which is also an open source product for running stress. So we can make sure these applications can handle load times. In our team, we have different roles, like app owners, like companies would have. For example, Jan and I, we own a separate application, and we are responsible for making sure we can upgrade them. Like, for example, Java Enterprise Edition to Jakarta, so we upgrade our applications, change to new features. So we should be having the same continuous integration, so we'll be talking more on that. And also, when the new versions come for our products, we need to test those, and those testers may not necessarily be the app owners. So we need to reduce easy to debug. We need to make sure other people can quickly run those applications without needing too much understanding of the applications. Also, as part of the test, we have production-like cluster, which we keep it for a long time. Lot of clusters we do is like short-lived, create it, test it, get rid of them. But we have long-running where we want to make sure we do, like if you're using OpenShift, upgrade them to the new OpenShift level and make sure your applications are still working fine, run continuous stress. So we want to make sure that our automation we are going to talk about is easy for that. So real quick goals for this automation would be, want to reduce those setup times for the application, quickly debug issues, because when tester runs one application like, oh, it's not working. So instead of going to their system, you need to have an easy way, and that's where this GitOps will help as well, and we will discuss more. And a production-like cluster, way to manage and disaster recovery. So we'll keep these goals in mind. And this is quickly like a workflow, how it looked like manually. So you are building your application image, pushing it to some image registry, deploy. We used to have DB2 and in VMs. So installing that, creating database, loading the data, and then deploying, deploying OpenShift cluster. And actually, you may have your deployment files, and then you will do kubectl to apply them, and then long run, again, deploy it in VM. So typically, for a new person, it can take some time. So after the GitOps, we will talk about, we have reduced that time because now we have set up scripts. We could do some of the bootstrapping, and after that, we create an argoCD app, which does all the deployment, all these things in italicized will be done automatically for us. So this is the reason I want you to, hopefully you will follow along here. Before we look at actual implementation, how we did it, I wanted to just touch on level set on the technical details of GitOps and argoCD. So although we love our graphical, UI, but we all agree that they are error prone, they are not repeatable. So most of us used to do scripting, right? You will create a server, add a server, start, all those things. But then came infrastructure as a code, which kind of changed a lot of things, made things easier. Ansible, Terraform, so you started to make things declarative. Tell what kind of nodes you want, give what size, and it will just create it for you. So infrastructure as a code is like process of provisioning and managing infrastructure as code. And we loved it so much, we extended it to configuration. And Kubernetes came, and it's purely declarative, right? You have your config files, everything. You tell it how many replicas you want. It creates things for you. So with infrastructure as a code, we are storing, most of us will store it in Git, right? It's in Git repository. We are probably doing some kind of version control with it. So there are two ways you are using, mostly using those. One way could be you will git clone your repo and then do kubectl on it. Or you might be doing it from your Jenkins or some kind of pipeline where the tool or your job is applying that. So what's the problem with this? Why do we have to think further? What are the issues with this? So let's say like on your cluster, you have pushed the changes, but if there is still possibility someone could log in and make changes, you have no idea what the state of your cluster is. Somebody could delete something, and then you have to reapply those. Also, all those people or the tools need to have credentials for your cluster. So I think these are some of the problems which we are trying to address using GitOps. Is hard to keep track of changes, and again, no formal review process for the changes which we are making to the infrastructure as code, and also you need access to the Kubernetes cluster. So with that, I think of GitOps as infrastructure as code plus. Like you still have that. You need to have your all the configuration in declarative, but now you have created the process, the best practices we use for code, like making sure you create a PR when you want to make a change, test it once you change it before pushing to the main, get it reviewed. So all those things you want to apply to your code as well. The second most important thing is using Git as single source of truth. What that means here is that you have your desired state in Git. So this is your Git repository having all the files declarative there. And then your cluster, which you want that to be the same as the desired state. So how do you make this happen? How do you keep your cluster always in sync with what you have in repository is the challenge which we need to figure out. This is what GitOps suggests, the framework suggests that we should do, but how do you make that happen? You need some kind of agent, right? Either pull or push. So in this case, what we are saying is if you are doing, so if we keep this model, we are saying that it will be repeatable, it will give us repeatability, stability, and consistency. So this is a next, we talked about we need some agent on either side, either pull or push. So in this case, we are doing a pull model. So we have agent sitting on your Kubernetes cluster, which is constantly monitoring your Git repo and is responsible for keeping it in sync. So making sure your actual state stays same as your desired state. So it constantly monitoring the Git repo. So in this case, what you're doing is your argoCD is one which needs credentials to your Git. And the problem we talked earlier about is now if someone makes change to your cluster, Kubernetes cluster, it's going to get overwritten, right? Like it will be detected that there is a configuration drift, something has changed, and depending on how you set up your argoCD, whether you do manual or automatic, if you did automatic, it's just going to, boom, like overwrite whatever was changed. If you did manual, you have ability to see what's changed and then keep it in sync. So this is our flow, what we are using this technology. So this is our GitOps flow. Again, we keep all our files for deployment files in the Git repo there. And if someone wants to, cluster admin wants to make a change, that will go, they will create a PR and GitHub to GitHub, that change will be reviewed, merged, and Argo will detect that and keep it in sync. So this is our GitOps flow. But for this to work, we need to have some way of having integrated with the CI pipeline. Is, as I mentioned, we have a lot of applications. So those are the app developers there. So they make a change to their code. Let's say a new version came. for your app, you want to make some application updates. And we are using Travis CI here for automatically building the container images and pushing it to the image registry, but you could use any other tool, Jenkins or whatever you like. And here we used Artifactory for keeping all our images. And those image and tagging, again, GitOps caused us to that we should have a consistent way of tagging all our images so that we, if we need, someone could just quickly deploy all, so they don't even have to go through the CI pipeline as well. And the same way we are also, as we are doing with the app development, we are also doing like DB2 images and Jmeter images and other prereqs as well. So we started to build those images from the container images and use the same pipeline to even deploy our prereqs on the Kubernetes cluster as well. And Dan will have the demo for that. All right, I'll pass over to you, Dan.
Yep. Thank you, Monica. Okay, so I'm going to start with, if anyone has any questions, because we're going to get pretty technical here. If I'm going too fast, feel free to just let me know. So we started with just a very simple app deployment as proof of concept. What we did was we installed the Red Hat OpenShift GitOps operator, which came with argoCD. We gave it permissions to deploy on our cluster. We then created a Git repository to store all of our deployment files. And then we configured Argo, which means we gave it the Git repository, the directory where the deployment files are, and boom. And like Monica said, we expanded our coverage to have DB2 and Jmeter. These were tasks that weren't very trivial on their own. We had to containerize Jmeter, and then we created common container images containing scripts for all of our applications. And then once we had those created, we added our deployment files for both DB2 and Jmeter to our GitOps repo. And keep in mind in here, the order of the deployment's important. We then also expanded our coverage to include operator deployment. We utilize an app of apps pattern, which is something I'll touch on later. And then we, as well, added the deployment files to configure and set up the OpenLiberty and WebSphere Liberty operators into the GitOps repo. And like before, the order of the deployment is also very important. So I mentioned the order of the deployment. Argo lets us achieve that order of deployment using waves. So the way the waves work is it deploys every resource in the lowest wave number. So say we have wave 1, that's our namespace. Obviously in Kubernetes, you need that first. It deploys that. Once that's ready, it goes on to wave 2. It gives the role bindings. Once all those are on the cluster and ready, on to wave 3. So the operator install, once that's ready, on to DB2. Once that's ready, on to the app. And then once the app is ready, on to Jmeter. So we finally have our stress test running. Now the app of apps patterns I mentioned. When I say application here, I mean the argoCD custom resource application. It's confusing. I know, I wish they called it something else, but it's called application, so just bear with me. Pretty much the application is just an object that points to the directory of where your deployment files are, and the Git repo and the directory, which branch you want to use, and then as well as where you want to deploy it. And this enables us, an app of apps pattern, enables us to use modular deployment, but can cluster the Argo console if that's something you use, which you can go without using it. And the idea is you have one application custom resource deploy other custom resources. Yep, and now we have our demo. There may be some static when I switch from the PowerPoint, so just bear with me.
Yeah, while Dan is changing that, one thing some people ask, like, why you chose argoCD versus Flux. So I think for us, we do a lot of testing on OpenShift. We do on Kubernetes as well. So we saw that there was a OpenShift GitOps operator which used argoCD, and argoCD was also available on other Kubernetes also. So we just picked that, and it was interesting to know FluxCD. So they are, I think, both good. It's one versus other, right? Whether it be like Honda versus Toyota. I think like once this has better features than others.
Yep. So for us, for our install, not sure if everyone's familiar with OpenShift and their operators, but the way we installed it was we just went to the operators, so an operator hub, then we searched GitOps here, and argoCD is the community one. FluxCD is a great one as well, and like Monica said, we just used Red Hat OpenShift one, which comes packaged with argoCD. And once there, we installed it. If you're on Kubernetes, the steps would be similar. They have very easy setup just with the Helm chart and other ways as well. So once that's installed, it created a namespace called OpenShift GitOps. So we will go there. And then it created the Argo instance here, which I already have here. And then once you're there, you would, pretty easy, you just go to the top, create new app, and then application name. So let's say day trader, project, meaning which group of applications, just keep it as default. Sync policy, meaning if there's a change, do you want it to happen automatically or only when you tell it to? I just usually hit auto create namespace. And here we have the repository URL. So I'm just going to skip this for now because I already have it deployed. And then the path where it would be. So, nope. And after that, you would have your destination. So we want it locally, and which namespace. Now, taking a look here, you edit it as a YAML. So this creates the application object that I mentioned before. So you don't have to do it through the UI. I find it helpful to create it in the console, and once you have it set up once, you could just copy this YAML and then apply it, and then never have to go to the console if you ever wanted to. And now I already have this deployed in essence of time. Don't want to bore everyone watching it deploy. We have it set up to this directory right here. So we have argoCD right here set to this Git repo with this path, which is linked to here. So Argo checks in this repo, sees, hey, there's all these deployment files, gathers them up, and then deploys them to the cluster where we told it to. And now inside this directory, we have another kind Argo application, which same thing, pointing to a different repo, tells you where you want it. So we want the same namespace. And this one is pointing to here, and specifically the deploy directory, where we have just our role bindings for the application. We have our DB2 in this folder, the DB2 specific things. We have our Jmeter specific. And then, of course, up here, the application deployment itself. And we specified the waves I mentioned before of Argo with these annotations right here. So every resource you have, sorry, I forgot to ask, can everyone read this? Good? Okay. A little small? Better? Mm-hmm. Yep, so right here, you just add an annotation saying what wave you want, and then Argo would notice that annotation and put it in that specific wave. So now that we have it deployed here, yep, so we have this one already deployed. It says it's healthy, synced up. Let's say you're, I don't know, it's your retail company and it's Black Friday. You need more memory to your deployments. So here where we have our application, we would go in here, edit it. For the Open Liberty application, we have the ability to change the requests and limits similar to just normal deployments. So let's increase the CPU here from 250 to, I don't know, 500. And then we would just commit that.
Generally, you would create a...
Generally, you would do PR. Yep. Just to save time. Yep. So then argoCD pulls every 2 or 3 minutes. However, you could just hit refresh, and then it'll check. Yep, so it pops up saying, hey, you're out of sync from the repo. And has a cool little feature here. You can see, OK, what's different? You go down, and it should, yep, right here. So 250 to 500. And then if you had sync status set to automatic, it would automatically update it. But in our case, we don't want that. So we do out of sync only, just hit sync. And it should be synced up. This one may need to be refreshed. Yep, so this still has the old 250. Now that it says sync, sync OK. We should just have to reload it. Nope, not yet. Oh, looks like it's scaled up. Yep, OK, so it has it here in the iterator 7.1. But you get the idea. It caught the change, and it automatically updated it. It also has a nifty feature. So say someone pushed a change that kind of broke the whole thing, and instead of scouring Git to look for it, you just want an easy way to roll it back to a previous commit. You could just go here, history and rollback. You could see here the different commits. You could see who to blame. And then if you wanted to, just roll back. Yep, and now we're going to go back to the presentation. It may go static again. I'm sorry about this. Oh, OK. Never mind then. So here's just a graphical look of what I showed you with our repo. So we then developed what we call our GitOps v1 repo, which we had all of our deployment files in a repo, and we had it separated by application. So what we deployed was DayTrader 7. We deployed it on OpenLiberty, so a directory below that. And we pointed Argo to that directory. And then Argo deployed it to OpenShift Kubernetes. A challenge we then hit in our journey was there was a lot of duplication. There were these 3 files for the operator deployments. They were essentially the same for everything, except just one small change between each. And as our repo grew larger, this became more and more of a problem and quite difficult to maintain. We then solved this using Kustomize, if anyone's heard of that. So what is Kustomize? It's a template-free way of customizing applications based on patching. If any of you have worked with Helm, it's similar purpose to that. It's built into kubectl, built into argoCD, and it's also open source. Now, how do we use Kustomize? So customization, it has a basis feature where you take a base and then you apply patches to it. Simple as that. You create the customization by creating a kind kustomize, and then the left you see the resources. You have what are the bases, and it could be in the same directory, or excuse me, the same Git repository. So you could do just the up to directories to operators and then OpenLiberty, or you can even use remote repositories as well. So Git and then a different one. And then you apply the patches in the bottom, and then it would create the YAMLs for you. So how we updated it was same idea with app and then platform. So DayTrader 7 OpenLiberty, say we wanted that. What we would do is we would point it to that directory like we did before. Argo would see that there's a customization in there. And then Kustomize would then pull in the files that were 2 up in the OpenLiberty operator. So those 3 common files that we often were using, and then pull them into there. Kustomize would apply the patches we needed, send it to Argo, and then Argo would deploy it to OpenShift and Kubernetes. So pretty much main takeaways, we were able to take away that duplication and isolate it just to one place. Next challenge we had was getting the host name. So as you know, GitOps is purely declarative, and that's great, but for us, our use case in SVT, we're constantly creating and deploying, creating and destroying new environments. The host name's not always the same for the user, and we really wanted our GitOps to be compatible with, kind of a one-size-fits-all for our generic purposes. And I think of it kind of like we were trying to fit a square hole into or square peg into the round hole. So it's pretty much that. So we created a way to dynamically find the host. We changed configuration, used a static service name that would be same for every cluster where we could. But in some cases, such as JMeter, that just wasn't possible. So we used the waves of argoCD to run a job, which would store the host or whatever variable we needed to a config map, and then pass that to the container. So for JMeter, we would have the app deployed, the job would get the host, and then the host would pass that to JMeter. So it's kind of going against the best practices of GitOps, but it's what worked for us. Then more recently, we used what we learned with Kustomize and app of apps. Like Monica mentioned, we have our production-like cluster, and we decided instead of going with our general purpose repo, we should just create our own, a separate one for it, one dedicated to that cluster. It's the similar idea in that we had the operators, but instead of having just the apps, we had an instance and a folder for each instance. Now in this instance, pretty much all it was is a customization, which we could pull in deployment files from the operators up top, or we could pull in deployment files from another repo. So we were able to pretty much just have a customization there, pulling in everything we need, modifying it to pull other ones we need, patching it all within there. So we didn't have to create new deployments for each app. If we wanted a high availability, we could copy a base and then just patch it. And then after that, we would just point Argo to the instance, Argo would deploy it, and then we have our deployed Argo, which this is once we created those applications pointing to the instance, we would kind of take note of it and put it in the deployed Argo. So just saying, hey, this is what we have deployed currently, and should something ever happen to that cluster, we would just point Argo to the deployed Argo and spin everything back up. Now, I went over a lot on the repo structure, and you may say, at some point during your GitOps journey, you'll say, how do I structure my repo? And to be honest, there's no right way to do it. It depends on your use case, and throughout our journey, we've gone through many, many different versions of it. You have different ways to organize it. You could do just different folder, different branch, or even a new repo. Oftentimes, it's a combination. So there's no perfect solution. It's really up to your use case.
Yeah, we had a lot of discussion on that.
Oh, yes.
We have to do pre-GA drivers testing, whether we make a change, like create another customize, versus just create a branch for pre-GA. So there are a lot of design discussions you have to have depending on your needs.
Yep, and as you saw, ours evolved, and in all likelihood, it will evolve further. It's just how it goes. The benefits. As you saw, it greatly reduces application deployment time. It gave us a bit of a cultural shift, more on collaboration, thanks to Git, as opposed, Git gives you that collaboration, as I'm sure all of you know. It gives us a lot of repeatability, which helps with debugging and potential regression. We're able to apply vulnerability fixes to containers, which, as of recently, has become very important. It also streamlined deployment for production server, and like I showed, with quick recovery.
I'll just add an example of how it enabled us. For example, we had these applications we wanted to add session persistence using InfiniSpan or DataGrid. So some other person was giving it a try with the new feature. So we said, okay, why don't you take this application, create a branch, give it a try. We updated whatever she needed to do. Did a demo of it, we liked it, reviewed it, integrated into whatever applications you want to do. And then you talk to your guest, to your production cluster operation person, and say, oh, this is feature, I think this is great for this, the applications running on production cluster, and review, get all those there. So this is something which really collaborate within the team.
Yep, I agree. Yep, then some other challenges we face. Kustomize, when you're first starting, it's quite picky for formatting. It also doesn't allow us to use argoCD's recursive feature. App of apps can often get too complicated. It's very difficult to follow at first and can be confusing. Argo's error handling, it's not the best. and that goes with Kustomize as well. And there's also a learning curve just for everything with GitOps, with Kustomize. So it could be a bit difficult at times to pick up. Pass it to Monica.
Yeah, so as Dan has shown you, like there are a lot of benefits we reaped out of this automation work. It was more of cultural change, also causing a lot of other areas like having more standardization for CI, and we talked about example of collaboration, being able to debug, like having when someone says, oh, this is not working, we can quickly look at our Git repo and see, okay, what's going on, or we can quickly fire up a new cluster, recreate the problem, and we talked about a lot of design issues which you have to think about, and they are going to be unique to your environment. So I would just encourage you to, if you are thinking about this, it might be worth giving it a try, starting small and evolving it as your needs grow. So with that, I hope next year you have something you want to share your story, how you are using it, and we would love to hear that as well. And these are some of the references. The top two are blogs. We are working on the series of blogs on our experiences, and some of the other are just getting started with the Open Liberty. Although we took Open Liberty as an example for runtime, but whatever we shared should work for any runtime. It's not limited to any of the products we mentioned here. Yeah.
Thank you, everyone.